Hey YouTube, this is Mike, and this is going to be part 3 in my series on how to code Ultimate Texas Hold'em. And before I get into that, I want to correct an error that I made in part 1, and that is in scoring flushes. This particular line here, which I address at the 19-minute and 52-second point in part 1 of this series. And what I did was I incorrectly had an R4 here and an R5 here when I'm looking at the smallest and the second smallest cards, which I should have been looking at, but in error I looked back at the highest and the second highest. And then I copied and pasted that same error down here if the player has nothing, which I call trash. And that error appears at the 25-minute and 8-second point in that video. So I'll do apologies there. So where we're at now is we're going to talk about scoring the dealer hand. And the way I look at pretty much all casino games is I start at the very last things that happen, and then I work back to the first things that happen. So let's do that. Right now I'm in Excel because I wrote out all the different ways a hand could play out in Ultimate Texas Hold'em. There's 3 things that matter: who won the hand between the player and the dealer, the poker value of the player's hand, which might value in terms of the which might matter in terms of the blind bet, and whether or not the dealer qualified, which matters for the ante-bet. So let's see. So I counted out. These are all the various ways that the hand could play out. There are 23 possibilities. So in this hand, in column B here, I wrote out the poker value of the player's hand, and I wrote them all out twice because it matters whether or not the dealer qualifies. As a reminder, if the dealer doesn't qualify, the ante-bet is an automatic push. It does not make any difference who wins. So if the player has a great winning hand, he's going to win 1 unit less if the dealer doesn't qualify, and that's important. So here's how much the player is going to win on the ante-bet. So D and Q stands for dealer doesn't qualify. So it's always going to be 0 if the dealer doesn't qualify, no matter what hand the player has. If the dealer does qualify, DQ stands for qualify. Then if the dealer wins, the ante wins -1, meaning it lost, and otherwise it pays even money regardless of the value of the player's hand. So the raise is similar to the ante in that it pays even money and you need to beat the dealer to win, except the raise always has action. This is why you see these ones here if the player won and the dealer didn't qualify. The player will still win on the raise. And the blind bet here, the player does still need to win, and these are the winning, what you get paid on the blind bet for these premium hands of a straight or more. And so this column G here adds up the win on the ante, the raise, and the blind. So you can see that it ranges from the worst case scenario is a loss of 3 units, assuming only a 1 unit raise, and we will deal with bigger raises later in the video, up to a win of 502 units if the player has a royal flush and the dealer qualified. So then what I did is I concatenate all of these possible wins, net wins, into this string here, and I'm going to copy and paste that into my program. So here we are back in C++, and I'm going to write a function that's going to evaluate all the things that could possibly happen when it gets to the dealer's turn and the dealer flips open his 2 cards. So let's make this function a double because it's I'm going to have it return the expected value, the player's expected value, if he makes the small raise. So I'm going to name the function dealer, and we're going to need to know the 5 community cards that the dealer may use. So let's call those C1 to C5. We're going to need to pass it the player's score to determine if the dealer beats that score. So we'll call that player score. And we're going to want to pass back some kind of array of everything that happened according to the 990 ways the dealer can pick, or should I say choose, 2 cards out of the remaining 45 in the deck. And make sure that number's right. 45, choose 2, yep, 990. So let's call that let's call that array the dealer event array. So before I do anything, let's create an array for the how many units the player can expect to win according to all the various ways the hand could play out that I just explained in Excel. So let's call that the small raise win, and let's make that an array. And let's go back to Excel, and here are all the number of units the player can expect to win. Whoops! Under the various ways that the cards could play out. So this array here is really important. If any of these numbers are wrong, then the whole program is not going to work. So I'm going to number all the possible events according to this array here. So, moving on. So let's loop through all the ways the dealer cards could come out. So we'll call them D1 and D2. So we'll start with D1. So that could be anything from 0 up to 50. And now let's check if that card is still in the deck, because maybe it's one of the community cards or the player has it. So I'm getting a little ahead of myself here. I'm going to create a global variable called deck, and it will simply have a 1 if the particular card in the deck is still there, and a 0 if it's not. And it will have 52, it will have a size of 52, 1 for each card. So we're going to say that if deck of card D1 is still in the deck, then we go on to the second dealer card. So that can start at 1 more than D1, and that can go up to 51. And now let's check if that card is in the deck. So at this point, we have 5 community cards and 2 dealer cards. So we're ready to score that hand. So let's create another variable called index. And index is going to call the convert function, which we made in part 2 of this series, and I'm going to pass it the 5 community cards D1 and D2. And I forgot a C up here. And let's create another variable. We'll call that dealer score. So dealer score is equal to the position in score 7 array of index. And now we can compare the dealer score to the player score. But first, let's see whether or not the dealer qualifies. And let's create another variable for that. We'll call it dealer qualify. So if dealer score is greater or equal to 371,293, which is the minimum, which is 13 to the, should be the 6th power, 13, 6yx, no, to the 5th power. So that's what you get. That's what the function that I previously wrote to score a hand will return for a pair. So if the dealer score, if any score is greater or equal to 371,293, then there's at least a pair. So that means the dealer qualifies. And we will say that this variable dealer qualify is equal to 1. Otherwise, it's equal to 0. So next, let's compare the player score to the dealer score. So first, let's write some code if the player wins. And let's separately handle it, whether or not the dealer qualifies. So if the dealer does qualify, then, and it just occurred to me before I forget, let's initialize that dealer event array. So there's 23 possible outcomes. So we cycle from 0 to 22. Okay. So at this line here that I'm working on, we know that the player won and the dealer qualified. So the way I set up that whole array is that, well, I forgot to do something. We need to find out the type of player hand that the player has. For example, is it a straight, a flush, full house, what have you, for purposes of the blind bet. So let's call that the poker category for the player. And that's going to be equal to the player score divided by 371,293. So let's go back to this line here. Again, at this point we know the player won and the dealer qualified. So we're going to increment our array by that value in the player category plus 13 to skip over situations where the dealer did not qualify, which have the lower numbers in that array, or the lower elements, I should say. So otherwise, whoops, that's in the wrong place. Otherwise, we do the same thing, but I'm only going to add a 2 to put everything in the same place. Moving right along, let's handle the situation where the dealer wins. So let's just copy and paste this line here and change the inequality sign. So now this code will get executed if the dealer wins. So the player is going to lose less if the dealer doesn't qualify. So I'm just going to copy and paste this code here. So if the dealer does qualify, that is going to count towards event number 12, and if he doesn't, it counts as event number 1. And again, refer to the spreadsheet portion of this video at the beginning to see all the different events and how they're numbered. So the only other possibility is that there is a tie, and that was element number 0. Okay, next we're ready to average what happens under all 990 ways these two dealer cards could come out. So let's cycle through all 23. And let's create a variable. We'll call it EV for the player's expected value, and we're going to initialize that to 0. And we have to make it a double because of that dreaded rule where the blind pays 3 to 2 if the player has a winning straight. Otherwise, we could deal with integers throughout most of this program. And to be honest, I was tempted to just double all the wins and then divide by 2 later, but I have screwed myself up in the past doing that. So I'm just going to keep everything nice and pure and keep that blind win at 1.5. So for any given possible event, we're going to add to it the number of times that it happened, which is in dealer event array, times what it pays. And you may recall that we store that in small raise win. And let's convert this to a double. We don't need to, but just in the interest of I don't know, just good looking code. And yeah, and nothing. So as I've said many times, there's 990 ways that the cards could fall out. So after we've cycled through all the calculating the expected value, let's divide it by 990 to get an average, and then we will return that expected value. Next, what I want to do is test the dealer function. So I'm going to use this calculator over at Wizard of Odds to check the expected value of a rather borderline hand. So let's say the player has a queen of spades and a king of diamonds, and the community cards are the 2 of clubs, 4 of diamonds, 6 of hearts, 8 of spades, and the 10 of spades. So this is telling us that the expected value of raising is negative 1.930303. The alternative being folding, of course, which has an expected value of negative 2. So here is a marginal raise hand. And by the way, you can use my 21 outs rule to evaluate situations like this, as long as I'm on the topic. We have 15 cards that can pair the board that the dealer might get, 5 times 3, as well as 4 aces. So there's 19 cards the dealer could get that would beat the player. And the rule of thumb is if there's 21 cards or more, then you fold. So here there's only 19, so it's a marginal raise. So let's go back to C++ and test out this hand there. So one thing I'm going to do is, I guess I did this before, is here is our array deck. And this is just the deck of cards, and I mentioned this before, but this is just going to represent whether a card is in the deck or not. So let's initialize that deck to be full. Okay, next, let's create a function. We'll call it test dealer. So just take it on faith that the cards that the 2-player cards are numbers 43, and let's just copy and paste that, 1, 2, 3, 4, 5, 6, and 45, and the community cards are numbers 0, 9, 18, 27, and 35. So let's pass to the dealer function. So first we pass to it, I don't remember, the 5 community cards. So those are, as I just said, 0, 9, 18, 27, and 35. Then we pass to it the player score, and just take it on faith that that is 337,575, and you can look at my logic from video number 1 to see how I arrive at that number. And we need to create an array for the dealer events. And I believe it was size 23, yes. So we're going to pass that. And let's output that expected value. And let's declare this function at the beginning. And we also need to declare the dealer function. We forgot to do that. And now let's call the dealer function. We don't need to test the scoring anymore. We already did that. I made a stupid mistake here in the dealer function. Is when I'm checking to make sure that the card that the dealer might get is still in the deck, I need to check that it is a 1, not a 0. and I just found another stupid mistake, is when I'm going through the dealer function here and figuring out what happened, I'm forgetting to increment the dealer event array according to whatever happened. Right now it's basically just doing nothing. So I think I'm ready to compile this thing. And it compiled, and now let's run it. And here is the output. You can see that it's showing us an expected value of negative 1.9303, which agrees with my calculator over at Wizard of Odds. So I am happy as a clam so far. So next, let's work on the player's turn and river cards, and we will cycle through all those, and I think I will make a separate video for that. So thanks for watching this video, everyone, and I'll see you over in part 4. Bye.